Hello and welcome to this revision session for AQA A-Level Physics Paper 1, looking at the topic of mechanics. So in today's revision session we're going to look at how to answer examination questions on A-Level Physics Paper 1, in particular mechanics. So if we've been successful and we've learned in today's revision session, we should be able to answer A-Level Physics examination style questions, assess our understanding on A-Level Physics and in particular mechanics, and then understand what topics for mechanics we need to improve upon for AQA A-Level Physics. So how should you prepare for this revision session? So when you complete your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this left hand side section write down any working out or answers to the questions in the revision session. When you're doing this, make sure to write in full sentences and show your full working out, whilst in the right hand side write down any bits of information which you find useful or any hints and tips on answering questions from this revision session. After the revision session ends, write up these notes into a revision sheet for you to use independently. How should you be revising AQA A-Level Physics in general? Well, the first thing you should be doing is learning the key facts. So use the revision guides, the class workbooks, prep notes in the textbook to learn key ideas of the course. You may wish to make mind maps or write out notes yourself. The second step is to test yourself, is to retrieve your understanding. So use Caboodle, use Seneca, use knowledge checkers to quickly test your own knowledge, and you may wish to do this from your own cue cards. Then the third step is to practice exam style questions. So use examination preparation books, homework books, supervised study books, additional workbooks to help answer exam questions and mark your own work, and you may wish to even download your own exam past papers to do this. So the three steps will be learning the key facts, then testing yourself, and then practicing examination style questions. Now in this particular revision session we'll have three types of questions. The first type of question is a general check question, which is a basic question designed to probe your understanding of the key concepts of the topic. Then we have our checkpoint questions, which are the more challenging questions designed to place your knowledge and understanding of the topics into different contexts and applications. Then finally, the assessment point questions are past paper examination questions, which will mimic the type of questions found in the public examinations. So let's have a look at the key ideas of mechanics, starting with our general check questions. So the first question says, three coplanar forces act on an object. The vectors representing these three forces form a closed triangle. State the resultant force acting on the object. And then below shows an object in equilibrium. Firstly, draw a labelled triangle of forces. Then secondly, calculate the magnitude of force T. And then thirdly, state and explain the magnitude of the resultant of the forces 5 newtons and 12 newtons. So pause the video now, then unpause the video when you want to go through your answer. Right, for this first one, the key idea you've got to understand is if there's a closed triangle from drawing your vector diagram, well therefore the resultant force is 0, so the overall net force will be 0. So again, with this question 2.1, because the object's in equilibrium, you should have a triangle which is drawn to scale. All the arrows follow each other, head to tail, head to tail, head to tail, and you get a closed shape forming. Now in terms of the magnitude of force T, we've got to use, because it's going to be a right angle triangle that we're going to form, we can use the Pythagorean theorem. So we can say that t squared is equal to 5 squared plus 12 squared, which therefore is the square, t is equal to the square root of 169, which is going to equal 13 newtons. Now, state and explain the magnitude of the resultant forces. Well, the resultant in any direction overall, because it's an equilibrium, must be 0. So therefore you can say that the resultant of the 5 newtons and the 12 newtons are equal to t, but therefore they're in opposite directions to cancel out to give 0, so therefore the resultant force of T to equal out that magnitude of the other two must equal 13 newtons. In our next question, the first one says the diagram below shows all the forces acting on a particle. Given that the particle is in equilibrium, find the magnitude of force P. Then secondly, the diagram shows that all the forces on the particle in equilibrium. Find the magnitude of the forces P and Q. Then thirdly, show with a vector triangle that an object is in equilibrium if only these forces are acted upon it. 12 newtons acting east, 5 newtons acting north, and 13 newtons acting 23 degrees anti-clockwise from west. And then the forces below are in equilibrium, find the magnitude of force F. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, you understand that the particle's in equilibrium. So you know that the forces will form a closed loop when drawn head to tail, so you can use trigonometry. So you can see that actually it's going to be equal to 20 over cos 45, which is 28.3 newtons. Again, for this second question, we can resolve vertically and we can resolve horizontally. So vertically, you can see that the vertical component of Q is going to equal 120, and that the horizontal component of Q is going to equal P, because they've got to cancel out to give you a particle in equilibrium. So when you work it all through, you work out your vertical component of Q there, and you equate it there, so you can work it out to be equal to 156.6 newtons, and for P 100.7 newtons. Now in this next one, we will draw a scale diagram, so drawing your 12 newtons, 5 newtons, 30 newtons to scale. Because it's in equilibrium, it should form a closed triangle, because that's what objects do when they're in equilibrium. Now for the last question, again, you're going to have to resolve horizontally for F. Okay, so you can see the horizontal component of F is going to be equal to 7.1 newtons. Okay, and you can work it through like that, so you get your answer to be 16 newtons. The next question says, the diagram represents four coplanar tension forces acting on a joint in a structure. Calculate the horizontal component of the equilibrium force E. So pause the video now, then unpause the video when you want to go through your answer. Right, so what you're going to have to do is look to see the direction that all the objects are acting, and the objects acting to the left are going to have to equal the objects acting to the right, but you're also going to have to consider the horizontal component of each of those forces because they're acting at an angle. So what we can say is that 26 cos 20 plus 8 cos 70 is going to equal E cos theta plus 32 cos 60 to equal it through. We can then work through all the values and then equate it to be E cos theta, which is equal to 11.17 newtons. The next question says, below shows a meter ruler pivoted at the 50 centimeter mark. Two objects of weight 0.70 newtons and W are placed on the ruler to balance it. Assuming the weight of the ruler is negligible, calculate the size of W and the force acting on the pivot. Then for the second question, below shows a model of a loaded section of a bridge made using a uniform wooden beam. The wooden beam is 120 centimeters long and has a weight of 15 newtons. One end of the beam rests on a support and the other end is fixed to a vertical string. Calculate the vertical force R at the support. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer these questions? Well, you can see that when an object's in equilibrium, that the clockwise moment about the pivot will equal the anti-clockwise moments about the pivot, and the forces acting upwards will equal the force acting down. And those two principles are always the case when an object is balanced. So you can work out your clockwise moment by doing 0.14, converting centimeters into meters, times by that force, W, because moment is force times by distance, equal 0.70 times by 0.32. We rearrange it, make W the subject, and we get 1.6 newtons. We can then also say the total force down equals the total force up because it's balanced. So therefore, the force up, R, is equal to 0.70 plus 1.6, which is 2.3 newtons. Now in this next one, we once again use the principle that clockwise equals anti-clockwise moments. We can see that R is going to cause a clockwise moment, and you can work it through by saying R times by 1.20, because we know that it's being supported at the tension point, which is at the other end of the beam, which is 1.2 meters away, equals 15 times by 0.60 plus 13 times by 0.40. Looking at where all they are from the actual string, you can see that's their distances. So you work out R to equal 12. We then say force up equals force down. We know that there's 15 acting down. We know that there's 13 acting down. We know that there's 12 acting up from R. So therefore T must equal 16 to cancel the other two through. The next question says, a uniform cylinder has a height of 10 centimeters and a diameter of 3 centimeters. The cylinder is placed with its circular base resting on a horizontal table. Calculate the maximum angle at which it can tip before it continues to fall on itself. Then calculate the magnitude of the forces below. So pause the video now, then unpause the video when you want to go through your answers. Right, in this first one, you've got to understand that the line of action which is produced by the weight must fall below the base. So when you actually draw it out, you can see that you're going to get your right angle triangle, and you can have your opposite and your adjacent. Okay, your opposite being the diameter and the adjacent being half of the height. So you can say it's 1.5 over 5, so therefore theta equals 17. And again in the second one, it's once again these idea of moments. It's the idea that clockwise equals anti-clockwise moments. You look across here, and the difference from the previous question is that now F is at an angle, and we've got to only consider the vertical component, because it's only the vertical component of the force that is producing the moment. So we're not using F in our equation, rather we're using F sine theta. So we equate the anti-clockwise and clockwise moments, we make F the subject, we then pop in all the values, and we say F is equal to 30 newtons. The next question says, a horizontal beam carries two concentrated loads. The beam is attached to a wall by a pin joint at point A. The beam is supported by a cable between points B and C. Calculate the force F in the cable. So, pause the video now, then unpause the video when you want to go through your answer. Right, again, similarly to those previous questions, we want to look at working out the values, and we know that if it's actually in equilibrium, we know that anti-clockwise equals clockwise moment. We also know that F is actually got a vertical component, so we've got to actually work out what it would work through with the angles. So we can work out the clockwise moment. We can say that the anti-clockwise is equal to 1.2 times by F sine 35, so we can work it all through, and then F is equal to 21.06 kilonewtons. The next question says, the velocity time graph for a car travelling on a straight road is shown below. Without carrying out calculations, firstly describe how the acceleration of the car varies between t equals 0 and t equals 100 seconds. Then determine the total distance travelled by the car in 100 seconds. Then determine the average velocity of the car. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first question, you've got to think about what the graph shows. So for velocity time graph, the gradient shows the acceleration. So from t is equal to 0 to t equals 75, we've got a constant acceleration. Then after 75 seconds, we've got no acceleration, so a constant velocity of 15 meters per second. Now the total distance travelled is the area under the line, which is the area of the triangle plus the area of the rectangle. We work it through, we add them together, and we get 940 meters. Now we can work out the average velocity because it's going to be the displacement divided by the time. In the previous question, we worked out the displacement, which was 937.5, which we rounded to 940. We then divide by the time of the journey, which is 100 seconds, so it's 9.4 meters per second. The next question says, the velocity time graph for a sprinter running along a straight track is shown below. So calculate the total distance travelled by the runner in 13 seconds, then calculate the average velocity of the runner. So pause the video now, then unpause the video when you want to go through your answer. Right, like in that similar question, how do you work out the total distance in the velocity time graph? Well, it's the area under the line. So you can split up the area under the line into three different shapes. You've got your triangle, you've got your rectangle, and you've got your trapezium in those three different segments. So again, you work out the area of the triangle with a half base times height. We then work out the area of the rectangle with base times by height. And then again, we work out what the area of the trapezium is with a half base times height. So you work it all through and you get 100 meters. Then the average velocity again is your total displacement divided by your total time. We've just worked out that the displacement is 100 meters. We can see on the graph that the time is 13 seconds, so it's 7.7 meters per second. In our next question, it says a ball is given an initial velocity up a ramp. The subsequent motion of the ball is illustrated below. Firstly, describe the motion of the ball. Secondly, calculate the total distance travelled by the ball up and down the ramp. Thirdly, what is the average speed and average velocity of the ball between t equals 0 and t equals 8 seconds? Explain your answer. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, it's very important you understand what the different things show. So a line sloping downwards is going to show a negative acceleration or deceleration. And when it's actually under the line, that again is a negative acceleration, but that's not a deceleration, rather that's an acceleration in the opposite direction. So the three steps are, you've got a constant deceleration, then the object will stop at 4 seconds because v equals 0 at 4 seconds when it crosses the axis. Then after 4 seconds, it'll accelerate back to where it starts again, by going in the opposite direction. Now the total distance is the area under the line. Now it's important to note that distance travelled is a scalar, so you'd add the two sections under the line even though one is a plus and a negative because it's a scalar quantity. So you do a half base height because it's a triangle times by 2 because it's on either side of the line, so it's 16 meters. Now the average speed is the distance divided by the time, so it's 16 meters divided by 8 seconds, so it's 2 meters per second. But the average velocity is the displacement over the time. Now the displacement is a vector, so you'd have to now subtract the two values from above the line and below the line, because now the negative makes a difference because it's got a direction. So it will be 0, not 16. So 0 over 8 gives you 0 meters per second. Now, the next question says, a car is on a road with a set of traffic lights ahead. The car starts from rest and the car then accelerates at a constant rate of 3 meters per second for 8 seconds. Calculate the velocity of the car after 8 seconds. Then the car then decelerates at a constant rate of 4 meters per second squared and stops at the traffic lights. Calculate the distance travelled by the car whilst it is decelerating. So pause the video now, then unpause the video when you want to go through your answers. Right, so because we've got constant acceleration and constant deceleration, we can use SUVAT, the equations of motion, to answer this question. So you can use V equals U plus AT, because we've got U, we've got A, we've got T, and we want to work out V. So you can pop in all those values and we get 24 meters per second. And it's the same thing here, apart from now we're decelerating. So the value for A has to be a negative number because we're decelerating. So we can use the equation V squared equals U squared plus 2AS, rearrange it to get S, the displacement in this situation, which is the same as the distance travelled in this case. Pop in all the values, work it through, and you get 72 meters. The next question says, tennis players can practice using a tennis ball machine. The machine projects tennis balls horizontally from a height of 2.54 meters as shown. Firstly, show that the time taken for the ball to reach the ground is about 0.7 seconds. Secondly, the ball lands on the ground at a horizontal distance of 17.89 meters from the machine. Calculate the velocity of the ball as is projected from the machine. Then, the initial velocity of the ball as it is projected from the machine can be increased. Explain how increasing the initial velocity would affect the angle at which the ball hits the ground. So pause the video now, then unpause the video when you want to go through your answer. Right, so this is an example of a projectile. So in a projectile, you've got to remember that vertically, you've got the force of weight acting down on the object, so you can work out acceleration from that. So we can just use SUVAT again, but this time our acceleration is 9.81 because it's being accelerated downwards by gravity, by its own weight. So you pop in all the values, work out T, and we get T to be 0.72 seconds. Now it's important to know that we're looking at horizontally what's going on. Now with a projectile, there are no forces acting horizontally, only vertically, so therefore you can use the equation speed equals distance over time in the horizontal. So we can say it's 17.89 over 0.72 because the time is the same both vertically and horizontally for a projected object, so we get 24.8 meters per second. Now if you think about what's going on, we've just said that the horizontal component, okay, is going to be larger because it's being projected further by the machine, which is projecting horizontally. The vertical component wouldn't be affected by this. It would still have the acceleration due to gravity on it, so you can therefore see what's happening in terms of the object's angle it hits the ground at. The next question says, firstly, state Newton's third law of motion. Then the figure below shows a satellite in orbit around the Earth. Show the forces that act on each body, and then state 3 properties of these forces that show them to be a Newton's third law pair. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important you understand Newton's third law of motion. It states that if a body A exerts a force on body B, then body B will exert an equal and opposite force of the same type on body A. So the diagram, there will only be one force on each body, the force from the centre of the satellite towards the centre of the Earth, and a force from the centre of the Earth towards the centre of the satellite, and they're both being gravitational attraction. Now, what properties indicate that something is a Newton's third law pair? Well, they'd have the same type of force, gravitational, the same magnitude, they'll act in opposite directions and act on 2 separate bodies, the Earth and the satellite. The next question says, the photograph shows a rocket. The rocket is launched vertically. The rocket's engines give a total upwards thrust of 7.3 times 10 to the 7 newtons. Calculate the initial acceleration of the rocket with the mass being 5 times 10 to the 6 kilograms. Then give one reason why the acceleration will increase as the rocket rises. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first question we're looking at Newton's second law, which is F equals ma, but F is the resultant force. So whilst there is a force acting upwards of thrust, there's also a force acting downwards of weight because it has a mass. So you work out that value of weight by doing mass times by gravity. You can then find out the overall resultant force by subtracting the thrust, so the weight from the thrust, so we get a value out there to be 2.39 times 10 to the 7 newtons. Acceleration is force over mass, so we get 4.78 meters per second. Now the acceleration will increase because as the object rises, the mass will decrease because fuel is used up, so therefore the thrust force will overall increase and the resultant force overall will increase. Let's now have a look at some checkpoint questions. So the first question says a force of 10 newtons acts on an object at an angle theta to the horizontal. Calculate the horizontal components of the force when theta equals 0, 45 and 90 degrees. Then a parasender is attached by a rope to a boat travelling at a constant velocity. The rope is angled at 35 degrees to the surface of the sea and the tension in the rope is 1650 newtons. Calculate the horizontal and vertical components in this rope. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, we've got to remember how to work out the horizontal component when you've got an angle at the horizontal, So therefore, it's actually the horizontal component is F cos theta. So it'll be 10 cos 0, 10 cos 45, 10 cos 90. That comes from the triangle that will be produced. And again, if you look at this idea that the angle is at 35 degrees to the surface of the sea, to the horizontal, we can say the horizontal is F cos theta and the vertical is F sin theta, and you can work out your two components that way. So you get 1352 newtons horizontally and 946 newtons vertically. The next question says, some students used a plank to make a bridge to cross a stream. The plank rested on a rock and a wall as shown. The plank is uniform. Firstly, show that the weight of the plank is about 250 newtons, with the mass of the plank being 25 kilograms. Determine the force exerted by the wall on the plank, and then a student of weight 550 newtons states that the plank will tip if she walks from the rock to the other end of the plank. Justify the student's statement. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first question, it's a really nice one. Weight is mass times by gravity, we get 245 newtons. The next one is you're looking at this object here, and because we've worked out a weight, the weight must be acting from the dead center downwards, which is 2.5 meters from either end. Okay, so therefore we can say that when we balance our moments now, because it's at rest, so therefore it's in equilibrium, we can say clockwise moments equals anti-clockwise moments. So it's 245, the weight, times by 2.5 meters, because it's acting on the dead center, equals F times by 3.6 meters, because that's how far away it is from the edge. So we get F to be equal to 170 newtons. Now, will it tip over? I think the best way to work it through is what is actually the moment you're producing, which is right at the other end of the plank, because that'll be the biggest moment. So you can say, well, it's actually going to be 550 newtons, which is her weight, times by 1.4, which is how far she can get away there. So she would get away to be 770 newtons. That's much larger than the 270 newtons produced on the other side. So therefore there's going to be a resultant moment, and that will cause the plank to tip. The next question says, the diagram shows a crane lifting a load. There's a large mass called a counterweight attached to the crane on the opposite side of the tower to the load. The horizontal distance from the load to the tower can be changed, and the horizontal distance from the counterweight to the tower can also be changed. Explain how the counterweight needs to move when the load is moved away from the tower. The beam is uniform with a weight of 3 times 10 to the 4 newtons, and the counterweight has a weight of 1.1 times 10 to the 5 newtons. The load has a weight of 4.4 times 10 to the 4 newtons. Deduce whether the load can be moved to the end of the beam without the crane toppling. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, you've got to understand what's going on to the principle of moments. So the total clockwise moment must balance the total anti-clockwise moment, so the overall moment is 0. So that the anti-clockwise moment is due to the counterweight, and the total clockwise moment is due to both the weight of the beam and the load that's acting on it. So if you increase the distance of the load, you'll increase the moment, because it's force times by distance. So therefore the distance of the counterweight also needs to increase the moment to balance it, because moment is force times by distance. Now Now in this next one, like we said, moment is force times by distance. We know where the centre of mass of the beam is going to be, so we can therefore use the principle of moments to equal that they must balance if it's going to actually work. So you pop in all the values, the anti-clockwise moments and the clockwise moments. You can look at the diagram to see if it's going to cause a clockwise or anti-clockwise moment. You then work out x to be 15.2 meters. Now 22 meters is the total distance it could possibly move on the crane, but after 15.2 meters it's no longer going to have a result. It's going to no longer be balanced because there's going to be a resultant moment. So therefore, if the beam was moved past 15.2 meters, there will be a resultant moment and the crane would topple. The next question says, a car is initially stationary. It has a constant acceleration of 2 meters per second squared. Calculate the velocity of the car after 10 seconds. Calculate the distance travelled by the car at the end of the 10 seconds. Calculate the time taken by the car to reach a velocity of 24 meters per second. Then in another example, a train accelerates steadily from 4 meters per second to 20 meters per second in 100 seconds. Calculate the acceleration of the train. From its initial and final velocities, calculate the average velocity of the train. And then thirdly, calculate the distance travelled by the train in a time of 100 seconds. So pause the video now, then unpause the video when you want to go through your answer. Once again, it's about constant acceleration, so we're using the equations of motion. We're using SUVAT. So the first one, v equals u plus at. Remember, it's initially stationary, so u equals 0 to get 20 meters per second. The second one, we can say s equals ut plus a half at squared. Once again, u is starting off as 0 because it's stationary, so you get 100 meters. And then rearrange v equals u plus at to get t equals v minus u over a, and we get 12 seconds out. In the next question again, a is equal to v minus u over t. You've got v, you've got u, you've got t in the information, so you get 0.16 meters per second. Now, the average velocity is the mean of the initial and the final, so it's the initial and the final added together, divided by 2, so we get 12 meters per second. And then the distance travelled by the train in this time is going to be, if you think about it, it's working through to be speed is distance over time. So therefore we can say distance is speed times time when we're using the average speed. So it's the 12 times by 100, it's 1,200 meters. In the next question, a car is moving at 8 meters per second. The driver makes it accelerate at 1 meter per second squared for a distance of 18 meters. What is the final velocity of the car? The second question says trials on the surface of a new road show that when the car skids to a halt, its acceleration is minus 7 meters per second squared. Estimate the skid to stop distance of a car travelling at a speed limit of 30 meters per second. And then at the scene of an accident on a country road, police find skid marks stretching for 50 meters. Tests on the road surface show that a skidding car decelerated 6.5 meters per second squared. Was the car which skidded exceeding the speed limit of 25 meters per second on this road? So pause the video now, then unpause the video when you want to go through your answer. Right, again, we're using SUVAT because we've got constant acceleration or deceleration. So this first one, we can use v squared equals u squared plus 2as because we've got all the information there. We can then work out what our value is going to be for v by doing the square root of u squared plus 2as, pop in all the values as shown on the screen, and we get 10 meters per second. In this next one, we're looking at distance. So again, we can say s equals v squared minus u squared over 2a. We know that v is u because it's stopped. Okay, we know that v is 0, because it's stopped, and u is 30 because it tells you in the question. You've got acceleration being minus 7, so you can work it all through, and we get 64 meters. The next one, again, we're trying to work out if it was above the speed limit. So we're trying to work out the initial velocity. Now we know the final velocity is going to be 0 because it's stopped moving. We know that acceleration is minus 6.5 because it's decelerating. So we pop those into the SUVAT equations and we get 25.5 meters per second. So we give our conclusion it was just above the speed limit. The next question says, a vehicle accelerated from 13.4 meters per second to 22.3 meters per second in 8 seconds. Calculate the distance travelled. Then a runner changes her velocity from 3.2 meters per second to 4.2 meters per second. In this time, she travels 200 meters. Calculate her acceleration. Then in 2009, Usain Bolt sprinted 100 meters in 9.58 seconds, setting a new record. If he travelled at a constant acceleration from start to finish, what's his acceleration? Then a dragster travels 0.25 miles in the time of 4.6 seconds along a straight track from a standing start. 1 mile is 1,600 meters, so calculate acceleration and final velocity. So pause the video now, then unpause the video when you want to go through your answer. Right, so in this first one, we're using suvat again. So again, we know that we want to work out S, so it's a half U plus V times by T, pop in all the values, and we get 155 meters. Once again, suvat, but this time we're doing V squared equals U squared plus 2AS, pop in all the values, make A the subject, and we get 0.019 meters per second squared. The next one again, we're using a suvat of S equals UT plus a half AT squared. We can make A the subject by doing 2S over T squared, pop in our values, and we get 2.2 meters per second squared. Then again, we're using suvat with S equals UT plus a half AT squared, make A the subject, sub in all the values, and we get 38 meters per second squared, and we then use V equals U plus AT to work out what V would be, and it's 170 meters per second. The next question said a boy was throwing a ball towards a wall. The wall was 5 meters from the boy, and the top of the wall was 3 meters above the point where the boy released the ball. The boy tried to throw the ball over the wall, but sometimes the ball hit the wall. In one attempt, the boy threw the ball with an initial velocity of 9.70 meters per second at an angle to the horizontal of 49 degrees. That showed that the ball traveled the distance to the wall in about 0.8 seconds, and then deduce whether the ball went over the wall for this attempt. So pause the video now, then unpause the video when you want to go through your answer. Right, again, it's a projectile question this time, so the only force acting upon it is the force of weight acting downwards in the vertical. So what can we do? Well, we can use the horizontal. Remember, the horizontal, there's no forces acting on it, so we can use the equation speed equals distance over time. So time is going to be equal to distance over speed, but we've got to work out the horizontal component of that velocity. So it's 9.7 cos 49 to get to be 6.36, and we say time is 5 over 6.36, so it's 0.786 seconds. Now, in this particular attempt, did it go over the wall? Well, we've got to look at its vertical displacement. So we've got to use suvat and work out what the value of S is. So we can say, well, S equals UT plus a half AT squared. Now, remember two things. Firstly, we're looking at the vertical velocity. So we're going to have to resolve 9.7 into its vertical velocity. So it's 9.7 sine 45. And secondly, the acceleration is against gravity because it's going upwards and gravity acts downwards. So it's minus 9.81, so we get 2.72 meters, which is less than 3 meters, so it doesn't go over the wall. The next question says a cannonball is fired horizontally from a cliff top 44.1 meters above the sea. The initial horizontal velocity of the cannonball is 304 meters per second. Calculate the time of flight, the horizontal distance it travels. Then an arrow is fired horizontally at 49.2 meters per second from a 29.4 meter high castle. Calculate the resultant velocity when it hits the ground. And then a ball is kicked with an initial velocity of 15 meters per second at an angle of 30 degrees to the horizontal. Calculate the range of the ball. So pause the video now, then unpause the video when you want to go through your answer. Right, again, we're looking at projectiles, so if we look at the vertical, we can say that S equals UT plus a half AT squared. U will be 0 because it's vertically got no velocity at the start because it's only got horizontal velocity. So acceleration is G because it's being accelerated down by gravity. So we can say it's a half GT squared. Rearrange it, make T the subject. Remember, G is 9.81, so we work it out ultimately to T equals 3 seconds. Now the horizontal distance, we know again there's no acceleration in the horizontal direction. Speed is equal to a horizontal velocity times by time, so it's 304 times by 3, 912 meters. In this next question, we can work out the vertical motion by doing V squared equals U squared plus 2AS. Remember that when we're working it through, it's starting off with no vertical velocity because it's fired horizontally, so U is equal to 0. A is going to be 9.81 because it is gravity that's acting upon it, so V equals 24. In the horizontal, there's no acceleration because there's no resultant force, so the horizontal velocity is going to remain at 49.2 meters per second. So the resultant overall velocity is, by Pythagoras, horizontal and vertical components there. So it's V squared equals it's going to be horizontal squared plus vertical squared. So you work it through to be 54.7 meters per second, and you can work out your angle by doing again trig from the triangle level form by doing tan opposite over adjacent, so it's 26 degrees to the horizontal. Once again, what's the range of the ball going to be? Well, we know from the vertical motion that V equals U plus AT because we're going to use suvat in the vertical. We can resolve that initial velocity into the vertical component to be 15 sine 30, so you can work out T to be 1.53 seconds. T will be the same both horizontally and vertically. So now horizontally, V is 15 cos 30, but resulted in the horizontal. So S equals UT, so it's 13 times by 1.53, the time being the same in both the horizontal and the vertical. So the answer is 20 meters. The next question says, an archer fires an arrow horizontally at 110 meters per second at a target situated 50.0 meters away. The arrow leaves the bow at a vertical height of 1.6 meters. The top of the target is 12 meters above the ground and the bottom of the target is 0.40 meters above the ground. Calculate where the arrow hits the target. Then a plane is dropping with a constant horizontal velocity of 400 meters per second at a height of 250 meters. A box of emergency supplies is dropped vertically from the plane. So calculate the time taken for the box to reach the ground. Calculate the horizontal distance between the point where the box is released and the point where it lands. How the force horizontally is the plane from the box to when the box hits the ground, assuming the plane continues to fly at a constant velocity. How far vertically is the plane from the box when the box hits the ground, assuming the plane continues to fly at a constant velocity. Then third question, a football of mass 400 grams is thrown from a height of 2.4 meters with a velocity of 12 meters per second at an angle of 35 degrees above the horizontal. Calculate the horizontal component of the initial velocity of the ball, the vertical component of the initial velocity, the maximum vertical height above the ground reached by the ball, and the time of flight for the whole trajectory and the horizontal range of the ball when it hits the ground. Pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, again, we can do horizontally. Again, horizontally, we've talked about this before. Time is going to be distance over the horizontal velocity. 50 over 110 is 0.45 seconds. So we can now do vertically. We can say the only force is acceleration due to gravity. So therefore, A is going to equal G, which is 9.81. It's going to be negative 9.81 because it's going upwards. Okay, so therefore, you'd work it through to be minus 1.002 meters. So the dart hits at about 0.598 meters because it's 1.6 minus 1.002 because it's going downwards, so therefore it's 0.19 meters above the bottom of the target when you look at all the logic of it. The next question, vertically, there's acceleration due to gravity, so we use suvat, so S is equal to a half gt squared, rearrange for t, pop in the values. G is 9.81, so you get 7.14 seconds. Horizontal distance, well, there's no force horizontally. Distance is velocity times by time. 400 times by 7.14, 2,856 meters. Again, horizontally, there's no resultant force, so there's 0 meters horizontally between them because there's been no acceleration at any point. So they're traveling at the same velocity. But vertically, there is going to be a issue because since the plane's flying horizontally and there's no vertical acceleration, the vertical distance between the plane and the box remains constant. The initial vertical separation is the height of the plane, so therefore when the box hits the ground, the vertical distance between the plane and the box is still going to be 250 meters. In question 3, a horizontal component is going to be v cos theta because it's the angles to the horizontal, so we work it through to be 9.86 meters per second. Vertically, it's v sine theta, so 6.86 meters per second. The maximum height, well, we can say v squared equals u squared plus 2as, so for s equals v squared minus u squared over 2a. Now at the maximum height, v is equal to 0 because it's at the maximum height, so it hasn't got any more velocity. We pop in all the values. Remember, it's going upwards, so now a is minus 9.81 because it's against gravity, so we get 2.4 meters. It's already 2.4 meters above the ground when it starts, so therefore it's now 4.8 meters above the ground. Now the time taken for the flight, well, vertically we know that v equals u plus at, so t equals v minus u over a, so we can pop in all the numbers. Remember, a is minus because we're going upwards, so it's 0.7 seconds. Now we know that the time taken to reach the peak is a third of the journey, as it's travelled 2.4 meters to be 4.8 meters above the ground, so therefore the time taken in total is going to be 3 times 0.7, so it's going to be 1.7 seconds. Now, horizontally, distance is speed times by time, so it's 9.86, the horizontal velocity, multiplied by the time, which is constant for vertical and horizontal, so it's 1.70 seconds, so it's 16.6 meters. The next question says, a student of weight 600 newtons is standing on a weighing scales in a lift. The scales are calibrated to give readings in newtons. The lift moves upwards at a constant velocity, then decelerates to rest. As the lift moves, the student looks at the readings on the scales. Explain the readings on the scales. So pause the video now, then unpause the video when you want to go through your answer. Right, in this question you've got to remember that the force of the lift and the scales on the student is the reading on the scales, or it's the reaction force, which is the scale, or reading on the scales. At a constant speed, the resultant force on the student is going to be 0, so weight equals reaction force. So at a constant speed, the read on the scales will just be the weight, so it'll be 600 newtons. But as the lift decelerates, the reaction will be less than the weight now. So as the lift decelerates, there's a resultant force downwards on the student. So as the lift decelerates, the read on the scales will now be less than 600 newtons because the upward force on the student is now less than his weight. The next question. A railway engine is pushing a truck along the horizontal rails at a constant velocity as shown. The engine exerts a forward force of 1.2 times 10 to the 5 newtons on the truck. The engine also exerts a net backwards force of 1.5 times 10 to the 5 newtons on the rails. Firstly, complete the free body force diagram to show all the forces acting on the engine, and then a student suggests that the weight and the normal reaction force form a Newton's third law pair of forces. Explain why the student's suggestion is not correct. Refer to the features of a Newton's third law pair of forces. So pause the video now, then unpause the video when you want to go through your answer. Right, remember when you draw a free body diagram, the length of the arrow shows the size of the force. So you'll see here that the force from the rails is going to be larger than the force from the truck when you actually look at the situation going on. Now, as well, there'll be a force of air resistance acting against the motion of the object. So as a result, you can see it working through there. Now, it's not going to be a Newton's third law pair because a Newton's third law pair of forces has force of equal magnitude in opposite directions with the same type of force acting on two different bodies. Now, first, the two forces act on the same thing, one body, the engine, and secondly it's two different types of forces, gravitational and contact, so there can't be a Newton's third law pair. The next question says the engine of a motorboat provides a constant horizontal force. As the velocity of the boat increases, the resultant horizontal force on the boat decreases. Eventually the boat will travel at its terminal velocity. The constant horizontal force from the engine is 5.5 kilonewtons. Firstly, state what is meant by the resultant force. Then, at a certain time, the drag force on a boat is 3.1 kilonewtons. Calculate the acceleration of the boat at this time. The mass of the boat is 7.5 times 10 to the 3 kilograms. Then the terminal velocity of the boat is 4.8 meters per second. Calculate the output power of the engine. So pause the video now, then unpause the video when you want to go through your answer. Right, a resultant force is the vector sum of all the forces acting on the object. It's the single force which has the effect of all the other forces acting together. Now this next one, we're doing F equals ma, but remember it's the resultant force, so it's 5.5 minus 3.1 times by 10 to the 3, because it's kilonewtons, equals 7.5 times 10 to the 3 kilograms times by A, so A is equal to 0.32 meters per second squared. Now we can work out output power, because power is equal to force times by velocity. Now the force of the actual engine acting on itself is 5.5 times 10 to the 3 newtons, because we're not looking at the power of the boat, we're looking at the power of the engine, so it's the force of the engine times by that velocity of the engine, which will be the same as the boat because they're moving together, so it's 4.8 meters per second, so it's 2.64 times 10 to the 4 watts. The next question says, in each of the examples, explain whether any work is done by the force mentioned. Pulling a heavy sack along a rough ground. The force of gravity pulls you downwards when you fall off a wall. The tension in a string pulls a stone when you whirl it around in a circle at steady speed. The contact force of the bedroom floor stops you from falling into the room below. Then secondly, a man of mass 70 kilograms climbs a stairs of vertical height 2.5 meters. Calculate the work done against the force of gravity. Then a stone of weight 10 newtons falls from the top of a 250 meter high cliff. Calculate how much work is done by the force of gravity in pulling the stone to the foot of the cliff and how much energy is transferred to the stone. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, yes, there will be work being done because there's the work is being done against friction because it's being pulled along that rough ground. Again, yes, gravity is doing work to make you go faster. The third one, no, because it's moving at a steady speed, so therefore it's at a constant distance from the center of the circle, so therefore there's no work being done. And then the third one, again, no work is being done because you're not moving, there's no displacement. Now, what's the work done here? Work done is force times by displacement, which is mg times by displacement. Pop it all through and you get 1200 joules. Again here, work done is force times by displacement. It's 10 times by 25. It's 2500 joules. So how much energy is transferred to the stone? Well, if we ignore any work dissipated to the surroundings, it'll be that value of 2500 joules. The next question says, a car engine does 4,200 kilojoules of work in 1 minute. Calculate its output power in kilowatts. Then a particular car engine provides a force of 700 newtons when the car is moving at its top speed of 40 meters per second. Calculate how much work is done by the car's engine in 1 second. State the output power of the engine. And then in an experiment to measure a student's power, she times herself running up a flight of steps. Use the data to work out her useful power. Number of steps, 28. Height of each step, 20 centimeters. The acceleration is 9.81 meters per second. The mass of the student is 55 kilograms, and the time taken is 5.4 seconds. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, with power is work done over time, it's 4,200 times 10 to the 3, because it's kilojoules, divided by 60 seconds, so it's going to be 70,000 watts. Work done is force times by displacement, so it's force times by speed there, so it's going to be 700 times by 40, so therefore it's 28,000 joules. The output power is therefore going to be in 1 second, so it's 28,000 over 1, so it's 28 kilowatts. Our work here is being done against gravity, so it's force times by displacement in this context, so therefore it's going to be 55 times by 9.81 times by 28 times by 0.2, which is 3020. Power is work done over time, so it's then divided by 5.4 seconds to be 560 watts. The next question says, consider a ladder that a person can use to climb into the roof space of a building. When not in use, the ladder is stored in the roof space and the opening to the roof space is covered by a board. The board is hinged to the ceiling at one end. The ladder is attached to the board by a rail as shown below. A small block prevents the board from rotating into the roof space. The weight of the board and rail is 50 newtons. The weight acting on a distance from 0.45 meters from the hinge is shown. The total length of the ladder is 2.70 meters with 0.85 meters to the left of the hinge. The weight of the ladder is 54 newtons and the ladder is uniform. Explain why the ladder and the board remain in the position as shown, and a downwards force is required to rotate the board away from the block. The force is applied 0.80 meters from the hinge. Determine the magnitude of the force. So pause the video now, then unpause the video when you want to go through your answers. In this first one, it's the idea it's going to be in equilibrium ultimately. So if you work out the distance from the hinge to the centre of gravity, you can work it through, and therefore you can work out your clockwise moment to be 27 newton meters, because you can do force times by distance. Then you can work out your anti-clockwise moment by doing 50 times by 0.45 meters to get 22.5 newton meters. So from that you can see straight away that there's a clockwise moment greater than the anti-clockwise moment. So what's happening is the block needs to be there to produce another value for your anti-clockwise moment, so therefore the overall moment is going to be equal, so the overall moment is 0 because the clockwise moment is going to equal the anti-clockwise moment. So how can you work it through? So if you work out overall your resultant moment, you get it to be 4.5 newton meters. So therefore what force is required from this block? Well, we know that moment is force times by distance, so therefore we've got our overall moment needed to make sure it equals 0 to be 4.5 divided by your distance is 0.80 meters, so we get 5.63 newtons. The next question says, the crossbar challenge is a football contest in which competitors try and hit the crossbar of a goal by kicking a football from the penalty spot. The horizontal distance between the penalty spot and the crossbar is 11 meters. One competitor kicks a football with an initial velocity of 17 meters per second at an angle of 24 degrees to the horizontal. The football hits the crossbar. The effects of air resistance can be ignored. Firstly, calculate the horizontal component of the initial velocity of the football. Then, calculate the vertical component of the initial velocity of the football. Show the time taken for the football to travel from the penalty spot to crossbar is 0.71 seconds. The football is at a maximum height at its trajectory when it hits the crossbar. Calculate the height above the ground at which the football hits the crossbar. Then the next time the competitor tries the challenge, they kick the football at the same angle with an initial speed less than 17 meters per second. Stay where the football will hit the crossbar, pass over the crossbar, or pass under the crossbar and justify your answer. So pause the video now, then unpause the video when you want to go through your answer. Right, we can work out the horizontal component because it's f cos theta. We can work out the vertical component because it's f sine theta, so we can work them through there. Time taken, we'll look here really at the values given. So the horizontal is probably the one we want to look at because it's easy to work through. So horizontally, time is speed over velocity. We've got our horizontal distance, we've got our horizontal speed, so it's 0.17 seconds. Then we can use for the next one the vertical, so therefore we've got to use suvat because there's a resultant force force on it. So S equals ut plus a half at squared. A is minus 9.81 because it's going upwards against gravity, so we get our answer to be 2.4 meters. Now in the next one, it'll pass under the bar because the ball has a smaller vertical component of the velocity, so therefore when you look at the equation, it won't reach the same height because its velocity will be lower. The next question says, a trebuchet is a medieval catapult designed to project a rock over large distances. The simplified diagram of a trebuchet is shown. A rock is held in a sling. When the peg is removed, the counterweight falls and the rock is projected through the air. A student assumes that all the gravitational potential energy is transferred from the counterweight to the kinetic energy of the rock. Give 2 reasons why this is not correct. The rock was projected with a velocity of 41.5 meters per second at an angle of 30 degrees to the horizontal. The diagram shows the flight of the rock after it's left the trebuchet. The rock rises to a maximum height and then falls back to the same height as it releases height. At its release height. Calculate the horizontal distance travelled by the rock in this time. Then, the mass of the counterweight was reduced. The trebuchet was then used to project the rock again. Explain why the horizontal distance travelled by the rock decreased. So pause the video now, then unpause the video and you'll want to go through your answer. Right, in this first one, it won't do because the beam will gain kinetic energy and also gain gravitational potential energy, and also some work will be done against friction, so this energy will be dissipated to the surroundings. Now, how can you work this through? The next question, well, you can work out your vertical velocity and your horizontal velocity. Vertically, we use suvat, v equals u plus at. We know that v is going to equal 0, so we can work out t to be 2.12 seconds, times the same horizontally and vertically. We've got the horizontal velocity as 35.9 meters per second, so therefore we can say distance horizontally is the speed times the time. We've got the time, we've got the speed, we've also had to double the time, by the way. You'll notice that because that's the value to the maximum height, and then the overall length is the time, is going to be the time to the maximum height doubled because it's been reflected back down now, so we get our answer to be 152 meters. Now in the last question, the counterweight transfers less gravitational potential energy, so the transfer of kinetic energy to the rock will be reduced. So when released, the rock has a smaller vertical velocity, so the time of flight will be reduced, and there'll be a smaller value for the horizontal velocity as well. So thank you very much for carrying out this revision session. If you've been successful in this revision session, you should be able to answer A-level physics examination style questions, assess your understanding on A-level physics, and understand what topics you need to improve upon for A-level physics. Thank you so much for listening to this physics revision session on mechanics. Hope you found it very useful, and as always, have a lovely day.